Hello friends, now we are live. So sorry for 10 minutes of delay. Actually, at the last minute, some software stopped working, so we started it again. Okay. So in this live session, we are going to talk about Matlab basics, and this is the third lesson in that category. So in this video, we will be talking about how to use these arrays and other kind of structures in Matlab, and then we will be discussing about we will be discussing about some like how to do plotting. Okay, so let's wait for 1 minute and let's see if any other person is available for our class. Okay, I hope we will start in a soon. Okay, so coming back to in the meantime we will have some theoretical description like what exactly are array. So from your basic C programming you must have understand like array is a collection of the similar data types. So earlier when we created some variable in Matlab, so those variables are known as the scalars. Why? Because they have single row and the single columns. Now the arrays could have multiple rows or multiple columns simultaneously, and that can be plotted again. Okay, so now let's start uh, with all this. Okay, so as in our first class we mentioned like these arrays or these matrices, that means the uh, in Matlab everything is represented as a matrix. Okay, so let's so matrix is a kind of combination of these rows and columns. So these are, let's say, some columns and these are some rows. So any variable which is created in Matlab, that is represented like this. So let's say if I say if a has only one value which is represented in this red color, then we'll say it is a scalar because it is of, right now it is of 1 cross 1 matrix. Okay, so if it a matrix is of 1 cross 1 matrix, then it is termed as like it is an scalar. Now it could have multiple columns and single row. So let's say 1 4 5 6, these are the values. So if it has one row and multiple columns, then it is known as the row vector. Okay, now it could be the case now if I represent it by some green color, let's say 2 4 5 6 and 7. So right now it only have one column and multiple rows, so that means n cross 1. So n could be anything. So it is known as the column vector. Okay, the same. Okay, and now if there are some values at every point like this, that means if it is of n cross m cross m, or any other size of rows and any number of columns, then it is known as the matrix. Okay, so that is the very basic format. Now coming to the indexing of it, remember all these values which I have created here like 5 6, these are the values of it. Now come to the indexing part of it. So indexing means the location number. If I say it is 1 2 3 and 4, similarly it can start row number 1 2 3 4 and 5. So in Matlab indexing doesn't starts with the 0. Okay, so let's talk about a row vector first, and we also say it as arrays. So these are the index 1 2 3 4 5 and 6, and the value in it could be anything, right? So these inside is the value. So this is the index and these are the value. Okay, so this is about the arrays or matrices in Matlab. So let's create these variables in Matlab and then we will learn how to do different kind of operations on them. Okay, so let's switch over to Matlab now. Yeah, So in Matlab, let's close this one and let's change our working folder to something else. Demo. Done. Okay. Now if I want to create some row vector, then I will simply write a equals to 1 to 10. So this is a notation, column 10. So in this case, this will go from 1 to 10 at a difference of 1. So A's has been assigned 1, 2, 3, 4, 5, and so on. I can also write like A equals to 1 at a difference of 2 to 10. That means this middle number shows the gap. So now number will go from 1 to 10 at an interval of 2. Now 1, 3, 5, 7, and 9. Right? So there are several ways you can create it. So if you double click on this variable A, now you will see, yeah, a corresponding row vector has been created. So when I am saying row vector, that means it contains only single row and multiple columns. Okay. Now let's create some another column vector. So in order to create the column vector, I want then semicolon 3 semicolon 21 semicolon 35. So by this we create a next row. So this semicolon indicates the next number will go in a next row. So now if I double click on B, a column vector will be created. That means there's one column and multiple rows are there. Okay. So this is the simplest way to create these column vector and row vector. Now there are several operations like transpose and everything can be done. Let's say if there's a is a simple row vector. If I type C equals to A transpose, so in order to take a transpose, you have to put this single comma, single inverted comma, and then it will like this. The C will become a column vector. Similarly, column vector can be converted into row vector just by taking the transpose of it. Okay. Now this about like how we created single different values, right? So similarly, we can also create any value like 10 comma 23 comma 14 comma 45. So if we put a comma there, it indicates it goes into going into the next column. So it will create a row vector. Okay. A as a row vector. So there are several ways of creating this row vector. Okay, now next thing which comes into this category is like how to create how to access different values of this row vector or the column vector at the same time. Okay, so we will do that simultaneously. In the meantime, if anyone of you have doubt who has joined us, they can let us know by commenting on this video, okay, on the live chat session. Okay, so coming back here, so there is a function rand. So it generates some random value. So if you go to into the search bar and if you search rand, then it will give you all the possible combination. So it will open a new window. So let me add that window as well. Okay, so this is the window. In this, you if you see it about rand, then you will find it is a array type. We just have to pass the number like okay, rand uniformly distributed random numbers. You just have to pass the number. It will generate the corresponding rows and columns of the random numbers. And remember, all these random numbers will lie in the range of 0 to 1. So if I type now, let's say rand 1 comma 100, then you will find 100 numbers have been created. So I type like this 1 comma 100. So 1 is the row numbers and 100 is the columns. So it is one row and multiple columns. Okay. So let's CLC. Now here is the value of A. So we have created different numbers of A throughout it. Now I was talking about the accessing any specific value of this variable A. So let's say we want to access this 8th index, so we will simply write a bracket 8. So it will give us the corresponding value, right? And let's say if I want to access these values of a, so I will type, okay, it will a bracket from where we start 5 to 12. So it will give us these values from 5 to 12, and we can also assign these values to another variable c. So C variable is being created in which values from 5 to 12 are available. Okay, so these we have created. Now let's CLC. Okay, now we want to access from fourth to last value, right? So if I write a bracket simple colon, so it will give us all the values within the array. All the values will be available to us. Similarly, if I type a to 1 to AND, or let's say 4 to AND, so AND indicates the last index or in this variable, so it will print us all the values from 4 to the last index of this variable. So 8 1 to AND, all the values will be displayed here. Okay, so this was how to access the different values of a. Similarly, let's say we can also manipulate the values. Let's say I want to change the value of fifth location. So I will simply write a of 5 equals to 10. It will become 10. Okay, let's put semicolon at the end. Let's say a of 10 equals to 100. So 10th location will become 100. That means this one. Okay, I have to put enter here. The value has become 100. If we want to change multiple values, so that can also be done. Let's say 3 to 10 equals to 5. So what will happen? From 3 index to 10 index, all values will become 5. Everything has become 5 then. Okay, so this is how we can manipulate the arrays, and we can manipulate it. Okay, now coming to the matrices, the same operation we can also extend to the matrices as well. Okay, so let's clear all CLC and then clear all. Okay, bracket CLC. Now we will create a matrix of some random number. Let's say a equals to RAND. There are 10 comma 10, 10 comma 10 matrix of some random number. Here are they. Okay, now as you know, in matrix, if we want to access this number, so it is represented by its row number and the column number. So I have to write a bracket 5 comma 5. Okay, so it will give us the corresponding value. Yes, similarly, if I want to access these number, which are these highlighted one, so it belongs to third row, but column goes from 4 to 9. So I will write a third row comma column goes to 4 to 9. Simple, 4 colon 9. It will give us all the values which I have mentioned. Similarly, if I want to these values which are highlighted, so I will type a. Here rows goes 2 to 7, so 2 to 7 comma 5. 5 is the column number. All the values will be done here, right? Let's create CLC. So these are the operations. Now let's say if I wanted to access this matrix, this highlighted matrix within this entire matrix, and I can we can also assign to different values. So let's say d equals to a first row number. So rows varies from 3 to 8. So 3 to 8 comma, and column values varies 3 to 9. 3 to 9. Okay, let's see. So d will become the entire highlighted matrix only. Okay, CLC. Now there are several operations which we can perform on this. So we have learned till now, we have learned how to create this arrays, row vector or the column vector, and how to manipulate them. That means how to access any specific value of it, or how to put certain number into it, or how to change the value which have been allocated to that particular number or to that particular array. Okay, now come to different operations which we can run. So one of the basic operation or which required most of the time is the length of the array. Suppose you are doing some simulation of some experiment and you don't know exactly what is the length of that array or the vector. So we can also do that. So let's say b equals to rand 1 comma 100. Okay, so right now we know it is 100 of length, but in real simulation work we may not know. So we will write like there's a command length which returns the length of that particular variable. So if I type length of b, it will return 100. So b was here, so b was 100 random number, so it returns 100 only. Now let's try it with the matrix. So a is a matrix. Now let's see what it returns in a case of a matrix. So if I type length of a, then it will return 10. Oops, because length returns only one value. Okay, so let's make a some multiple values. Let's say 10 comma 50. Okay, it is a random matrix of 10 rows and 50 columns. Now let's type length a, so it will return the highest value out of these rows and columns, so it returns 50. So right now we don't know whether it is a row number and the column number. Now let's say in any case, if we are interested to know the rows and number of the columns of a matrix, then how should we write? So there is a command size, right? So it returns both the values. So if I type size b, so it returns 100. It returns two values. So one is the row, first is the row, second is the column. Okay, similarly, so let's type because it returns two values, so we are assigning those return value to two variables, r and c. So let's type size, and in size I type a. So it will return number of rows available in a in r and number of columns available in a in c. So if I type enter, so rows are 10 and columns are 50. So these can be very helpful in doing some simulations. Okay, now there are some and there are different mathematical operations which can be performed. So let's say they are b, right? So b is there, so if I type sum of b, it will give the sum of all of these numbers. If I type mean of b, it will return the mean value of this b. If I type var of b, it will return the variation. Similarly, if I type std, so it will do the standard deviation. So all these mathematical operations are directly available in Matlab at our fingertips, and we can simply use them directly. Now let's see what happens if we pass a matrix in them. Okay, so let's start with a. Remember, a is a 10 cross 50 matrix, so 10 rows and 50 columns are there. So we will assign the number in a different variable d. So d equals to sum of a. Okay, so now if you look at d, so it has returned you a 50 values vector. Why is that? Because when we say sum a, so it by default sum of column wise. That means it returns the sum of this one in one value, sum of this one in second, sum of this one in third, and sum of this in another. So that is how it has done if I type sum of a. Okay, so in order to verify it, let's say I type a simple command sum of a of only this column, first column. So how can I do that? So all the rows comma first column. So this will return all the values which are available in column 1 only, because in this for column 1 we are taking all the rows comma first column, and then all those return values are being summed here. So if I press enter, it will return 3.9818. And if we look at the first value of vector d, that is the same. So if I type this simple command sum a, it by default returns the sum column wise. Okay, and I hope you understand it now. Now let's say I want a sum call row wise, so I have to type, so let's say d equals to sum a comma, I have to type 2, and yes, a. Now it is sum of row wise. So because there are 10 rows, that is why the d is a 10 row matrix, 10 row vector, we can say. We can also verify the same by, let's say, sum of entire row. We want to the sum of this row, so how we will write sum of a bracket first row and all the columns. So we have typed like this, a 1 comma this and this, it will give us. So this is true for all other mathematical operations which we discussed, right? How to do sum, and similarly we can also do subtraction, mean, and standard deviation, variations, and everything. So we just have to make sure we are doing the right operation. That means we are taking either column wise or the row wise. So let's clear it. Now coming to the one of the important aspect is the multiplication in MATLAB, right? So why I'm saying it is a very important aspect, because there are two kind of multiplications in MATLAB. One is the matrix multiplication, and another one is the element by element multiplication. So if you recall about the matrix multiplication, that is very easy. So let's click to new, don't save. So let's say if we have two matrices, A and another matrix here. So there were certain conditions. If we want to multiply two different matrices, the number of the rows should be equal to the number of columns of it. Okay, right? So because yeah, should be number of columns should be equal to number of rows into the second matrix, right? So let's say if there is a matrix, these are 3, 5, 6, and then there is another column which is 5, 7, 8. So if we do a multiplication, it will be 3 into 5 plus 5 into 7 plus 6 into 8. Okay, and similarly it will go for all the rows of the second column. So number of columns of first matrix should be equal to the number of rows of the second column. That is the matrix multiplication. Now there is another multiplication as well when we try to do some kind of simulations. So let's say we have these values 1, 2, and up to 10 numbers. So we have one row and it contains different values, right? So let's say it contains different values which are available in it. So in that case, what can happen? Let's say this is a matrix A and there is a matrix B, and B also have of the same length 1 to 10, and again it contains different. Now what I want to do, you have to listen carefully. We want to multiply the first element of this A to the first element of this B, and second element to the second element, third element to the third, and so on. Okay, so generally we can say it as a element by element multiplication, but there may be some other name. Different authors can use different name, so I generally use the element by element method. That means all the elements should be multiplied to the corresponding values. So there are two operators correspondingly. One is the single and one is the dot. Similarly, it is also true for division purpose and power purpose. So if we want to do element by element power, we have to do like this. Okay, because let's say if I want to write this equation 3a square plus b. So in this case, in this a square, think about it like this. So what exactly we are doing here, we are making a square of each element and then plotting it, or doing some mathematical operation. Okay, so in that case, in MATLAB, it will be written like a dot this. Okay, so it indicates it is a squared of itself, of its numbers. Okay, now we will see how to do that in MATLAB. Okay, so let's create a simple matrix here. uh, okay, so it is becoming tough, so I think in this class we have to cut short. We will discuss plots in the next session. So in this class we will talk about only this arrays and vectors. So now let's say if I type a equals to 1 comma 3 comma 5 comma 2 comma 3 comma 5 comma okay, let's take some random numbers, random 3 comma 3, and b is also rand 3 comma. Okay, now if I write c equals to a into b, then we'll get a matrix 3 by 3. That's fine. But now let's say we have only single column, rand 1 comma 10, and b equals to rand 1 comma 10. Now if I want to multiply them so that the first element of a is multiplied with the first element of b, so I will write c equals to a into b, and it will throw an error. And many of you have encountered this kind of error while doing the programming part, because this is very general error which students get during the programming. Okay, so now let's change it, make CLC. Okay, so we will can write simple a into b, and now we'll get our variable c, which is the multiplication of these three numbers. Okay, so let's CLC. Okay, now so this is about different operations on arrays and matrices and other aspects. So if any whoever is listening, if anyone has some query, then they can let me know, and then we can have a short discussion on the live session only. If anyone of you have in doubt, you can let me know through this live chat. Okay, so let's wait for some time if anyone is available. Okay, so now moving forward, so let's take some example of this, right? And let's take a very simple example. Okay, and so this kind of example most of you must have done. So let's say we have a battery here and we have a resistance, and all the resistances are in series. So this is 2 ohm, 2 ohm, and 2 ohm, and this is plus 1, 10, right? What we want to know, we want to know the voltage drop across each resistance. Okay, so this is V1 voltage drop, right? And the voltage drop across the second is V2, and voltage drop across this third is V3, and here's the complete line. So we want to write a program so that if anyone want to enter the values of this series connector resistance, so through the program they can find these values varies. Okay, so let's see if we can do that. Okay, so go to Matlab. Yes, here, so let's create a new script. So we will write like this file computes the voltage drop across series connected. Close all, clear all, and then CLC. So we will ask from the user. So we'll contain all the values in R. So we'll take the entire vector simultaneously. We'll take it input. So enter series connected resistors, and then V equals to input source voltage, because that has to be known. Okay, so first of all, what we have to do, we have to find the current, total current, which is okay, sorry. So this was the sorry, I forgot to change the screen. So this is the input current, input resistance, and we are taking the source voltage, because first of all we need to current the total current going through this entire circuit. Okay, so first of all we will compute that. So let's say I equals to V by, now this R, we have to compute the sum of all the resistances. So we have to write, like we can use simple command sum of R. So it will compute the sum, and then voltage drop across each, we are representing it by small v. So V equals to, that is voltage drop, V equals to IR, I into R. So now this I is a scalar value, right? So we will have to multiply I into R. Okay, so let's save it. Demo series current. Okay, and then we will display this voltage drop across each resistance is, I will display a small bit. Okay, so let's run it. So first of all we'll check our value with two values, 1 comma 1. So we know in this case equal potential drop will be there. Enter the source voltage 10, 5 and 5. Let's run it again. That's 1 space 3 space 5 space 2 this one. So these are the resistances connected in series. Enter source voltage 10. The voltage drop across each one is 0.2 and also. Okay, so maximum voltage drop will across the maximum resistance. So that's what is happening here. So this is how we can write this simple script to some simulation problem. Okay, so I hope you have learned a new thing in Matlab, and with that we will close our today's session for this Matlab basics. Okay, and the remaining plot command we will discuss in next. Thank you. Okay, prior to that, one more thing I forgot. If anyone is having any doubt, and they can, right? I think there is an interrupt. Okay, so finally, we also provide online training in technical assignments. We also do a project based on data science, Python, machine learning, etc. If you have any such requirement, then you can let us know by contacting